Hello, welcome. Let's try to solve another Leetcode problem 2592, maximize the greatness of an array. So the problem is that we are given this kind of array nums, and we can permutate the nums in any order. So after the order, so for this example, this is the perm. We are going to check if the perm I more than nums I, and we are going to count how many of such pairs. So currently the pair is 4, so we're going to return a 4. I think the meaning of the problem is really easy to understand. So the problem is that we are going to calculate the maximum possible greatness, of the permutation. So my first idea is that maybe I'm gonna sort the nums. So after sorting of the nums, I will check the nums one by one. So for example, this is my current num. So for example, it is here. I'm going to find the next number that's gonna be bigger than this num. So if I find this number, I will remove it from my sorted list. So for this problem, I'm going to use a sorted list because I'm going to use a binary search. So this may be the first idea. So the second idea is the greedy idea. I can solve the problem directly after sorting. So the sorted list idea is that currently we're going to sort these nums, and it's going to be linear increasing. It's going to be monotonic increasing. And then I'm gonna check the nums one by one. So for each of the num, if I can find a number that's gonna be bigger than my current number, so I'm gonna count it as 1, and at the same time I'm gonna remove this number. So this is my first idea. So let's just use this method to solve the problem first. So from sorted containers, we're gonna import the sorted list. Now we're gonna use the sorted list directly, so it's gonna be the unsorted list. And before that, we're gonna sort the nums as I said, because this is something greedy idea. And then we're gonna put the nums inside the sorted list, and then we're gonna check the nums one by one. So for n in nums. Now, what we're gonna do? We're gonna check the index, and we're gonna use bisect. We're going to use bisect right. So it's going to be bisect right with this n. Currently for this index I, it means the next number is going to be more than this current number n. So can we find? So if this I is less than the length of the sorted list, it means we can find it. So what are we going to do? From the sorted list, we're going to remove this number. So this number is going to be n. I'm sorry, it is not n, it is SLI. It is the current number. It is the number which is greater than the current number. And then we're going to update the result. So finally, we're going to return the result. So the result, I'm going to set it at 0 from the beginning. Now let me just run it to have a basic check. From sorted containers, import sorted list. What did I did something wrong maybe. Let me check. Cannot import name sorted list. Because this is gonna be uppercase L, capital L. This should be capital L. Now as you can see, it works. But it's pretty slow. This time complexity is n log n, because here is a sort, and here is another sort n log n. So definitely this is a n log n time. But that is not so fast, and it's a little bit complicated, If somebody don't know the sorted list, how can they solve the problem? So the second idea and the second method gonna be the greedy idea. So still, we're gonna sort the nums. We're gonna sort it in increasing order. Now we're gonna use index I. So this idea is that the greedy idea is that after sorting the nums, so this is gonna be a line. So for this number, what are we gonna do? We're gonna find the So currently for this number, this is our number, and definitely we want to find the next number which be greater than this one, maybe this number. And what about this number? We're gonna find the next number which is gonna be bigger than this number, but the line can be like this. There's no decreasing. Let me make it right. So it's going to be like this maybe. So for example, this number, maybe we find this number here, this number we find this number here, or this number we find this number here. So this index is what we're gonna return. So this is the I, yeah. Now we're gonna check the nums one by one. So for n inside the nums, if this number n more than the nums I, so I gonna plus 1. This means we're gonna check the next number. So finally, we just need to return the index I. Actually, this is also the total number of greatness. Yeah. So now let me just submit it. Yeah, now as you can see, it works. Because the nums sort is really fast, that is why it is 92% of all submissions. And this method is really easy, and it is directly the greedy idea. Yeah, so the idea is that for each of the number, how can we find the maximum? Yeah, how can we find the maximum possible greatness? Yeah, that we can achieve by this number. So definitely we want to sort it. So after sort it, we know the properties of the nums array. So inside the nums array, we always, so for example, for this number, we always want to find a smaller number which is bigger than this one. Definitely for this number, we don't want to find this number. Yeah. So the greedy idea is that for this number, we have to find the next bigger number, next greater number bigger than this one. Yeah, so for example, this is 1, and this is 2. Definitely we're gonna choose 2. Instead of here, for example, this is 5. Instead of choosing 5. Yeah. So if we are going to choose 5, what happens if there's another number 4? Because we've already chosen 5, so there's no possibility to increase the number, but we want to maximize the possible numbers. So this is why instead of choosing the bigger numbers, we always want to choose the next greater number. So this is why the greedy idea works. Yeah, so I think that's all about it. Thank you for watching. See you next time.